All right, so standard electrode potential and Gibbs free energy. Now, we've seen Gibbs free energy. Now, we want to see how we can combine standard electrode potential and Gibbs free energy. Now, standard electrode potential and Gibbs free energy can be combined as, if I write this, what's this? Standard Gibbs free energy, right? Equal to minus NF E naught cell. Now the relationship between electrode potential, which is given as E naught cell, and standard change in Gibbs free energy is this. We already know that delta G naught is standard change in free energy, right? Or Gibbs free energy. Now N here represents the number of electrons. Number of electrons. F represents what? Faraday's constant, right? And you agree with me that Faraday's constant is equal to what? 96500 what? Or what? 964 what? 964 what? 8 what? 6. Don't worry, in reactions, in equations that they don't want you to use it, they'll give you the other one, the real value. Alright, so 96500 coulombs. And E naught cell is the electrode potential. Electrode potential. Now, one thing we have to note here is that E naught cell is used for redox reactions, oxidation reduction reactions, right? And if you want to calculate E naught cell is equal to E naught of reduction minus that of oxidation. So please take note. Now, if after calculation your E naught cell is positive, you can use this to predict if a reaction will be spontaneous or not. In our previous lesson, we've seen that we can use delta G to state if a reaction is spontaneous or not, right? We've said that if delta G now we've said before that if delta G is positive, is the reaction spontaneous or non-spontaneous? Non-spontaneous, right? Now, if delta G is negative, we say the reaction is what? Spontaneous. Now, for E naught cell, if after calculation your E naught cell is positive, we say the reaction is what? Spontaneous. But if it is negative, the reaction is what? Non-spontaneous. So you see, it's more of a reverse of delta G. So if E naught cell is positive, you say it's spontaneous. If it is negative, it is non-spontaneous. But if delta G is positive, it is non-spontaneous. And if it's negative, it is spontaneous. So this now, we are going to use a practical question to see how we can apply all this when it comes in question. So write this down, then let's see how we can apply it. Now the question, let's look at example 1. Calculate the delta G naught for the oxidation of NADH by FAD. Take the standard reduction potential E naught cell, E naught of FAD and NADH to be this and this respectively, and F to be this. Now I've said before that anytime you are answering a question like this, the first thing you have to do is to write your parameters. Apart from the fact that they can give you mark for that, it helps keep your work organized. So here we're giving, what were we giving? E naught for, okay, first, we can write the equation of reaction here because they didn't give us the equation of the reaction. They said calculate the delta G naught. Please listen attentively. For the oxidation of NADH by FAD. Now, from your knowledge of chemistry, oxidation is the addition of hydrogen or removal of hydrogen. Removal of hydrogen, right? Now, oxidation of NAD, meaning if NAD is undergoing oxidation, on the product side, are we going to have, we are going to remove hydrogen, right? To show that it has been oxidized, because oxidation means removal of hydrogen. So this is oxidized. So we said NADH is oxidized to NAD plus. But what is oxidizing it? It says oxidized by FAD, right? Now, normally this thing is supposed to be written as FAD2 plus. That is the right way of writing, not just FAD. Now, this is the oxidizing agent, right? What is oxidizing it? And you agree with me in chemistry that an oxidizing agent is always reduced at the end of the reaction, right? Now, if this is an oxidizing agent, at the end of the reaction it will be reduced, right? It means it will have hydrogen will be added to it, is it not? Now, since we have 2 plus here, the oxidation state here is 2 plus, we are going to be adding how many hydrogen? 2 hydrogen, FADH2. Now, if you've written that, the next thing is to balance it up. What is not balanced here? Look at it very well. Is hydrogen balanced? Alright, hydrogen is not balanced. On this side, we have how many hydrogen? 1. On this side, we have how many? So what do? Please, unlike your normal balancing of equation, you don't add 2 here to balance the hydrogen. Instead, you use hydrogen ions to balance this. So with this now, it's our hydrogen balance. Now, what is not balanced again? The charges, right? The total charge we have on this side is what? 3, right? Because 2 plus 1 will give us 3. The total charge we have here is what? So to balance it, what do? What you use to balance ions, you use electrons, right? You use electrons to balance ions. So where do I add the electron? Is it left or right? Left or right? Where do I add this electron? Left or right? How many? The total charge we have here is what? 3 plus, right? How many do I have here? 1 plus. So electrons, this is negative, right? So I want to reduce this one to 1. So I want to add the electrons here. So here you agree with me that we'll be having plus, what was here? NAD plus, what was here? FADH2, right? Is that all? Now here we have a total charge of how many? 3, right? And here we have a total charge of 1. So how many electrons will I use to balance? 2 electrons, right? Why? Because here we're having plus 3, right? And here we're having minus 2. Plus 3 minus 2 will give us what? Will give us what? Plus 1, right? 3 minus 2 now is plus 1. So the total charge we have on this side now is now plus 1. The total charge we have on this side is now plus 1. Everything is balanced. Now we can now solve. We were asked to find delta G naught, right? Delta G naught we don't know. We are giving E naught say, and we are giving E naught for FAD and E naught for NADH. But now look at this. The first step is to write the whole equation of reaction, the overall equation of reaction. The second step is to divide this overall equation into half equations. We have to divide this whole equation into half equation. And when they say half equation, you know this is a redox reaction, right? It means we have the oxidation half equation and the reduction half equation. So we'll divide it into oxidation half equation and reduction half equation. So our oxidation half equation, this one is undergoing what? Is it oxidation or reduction? Oxidation, right? So NADH to give us what? NAD plus. But this is not balanced, is it not? Hydrogen is not balanced. So what do I do here? This one hydrogen, here there's no hydrogen. So how do I balance it? I add one hydrogen here, right? Yeah. What's not balanced? The charge is not balanced, right? The total charge we have here is what? And the total charge we have here is what? So what do? I can add plus 2 electrons here, right? So that these two will cancel the effect of these two. It's balanced now. Now the reduction. This one is undergoing reduction, right? So we'll be having FAD2 plus to give FADH2. Now hydrogen is not balanced, right? So since hydrogen is not balanced, what do I do to balance hydrogen? I add 2 hydrogen here, right? 2 hydrogen ions. The total charge we have here is what? Is what? 3, right? The total charge we have here is what? Sorry, the total charge we have here is what? This 2 is affecting this now. So 2 plus 2 is 4, right? So to balance it, how many electrons do I add? 4 electrons. Everything is balanced. Now check. If we want to get the overall equation from these two, we will still get it. Because NADH, FADH2. How many hydrogen ions do we have here? 1, right? How many do we have here? But 1 is on this side. So this 1, we cancel 1 here. And we'll have this one. How many electrons do we have here? How many do we have here? 4. These 2, we cancel 2 here. We'll have this. So we still see we'll have our overall equation. But now we were given, for oxidation, that's NADH, we were given the reduction potential as what? So E0 for oxidation. It is for oxidation because we know that NADH undergoes oxidation, right? And this one undergoes reduction. So E0 for NADH was given as what? Minus what? 0.315 volts, right? They said FAD and NADH respectively, meaning this one is for FAD, this one is for NAD. So E0 say, E0 for reduction is given as what? Minus 0.219 volts. Now, from this, we can go on to calculate E0 say. The E0 say is given as what? E0 for what? Reduction minus E0 for what? Oxidation. So E0 say will be equal to E0 for reduction is what? Minus 0.219 minus E0 for oxidation is what? Minus 0.315. So this means that E0 say is equal to this minus this. Plus or minus? Plus what? 0.926 volts. Alright. Now we've gotten E0 say. But what were we asked to calculate? What were we asked to calculate? Delta G0, right? Is it not? We're asked to calculate delta G0 and we're giving F as 96485, right? I want to clean this. Now, what is the relationship between delta G0 and electrode potential? The relationship is delta G0 is equal to what? Minus what? NF E0 cell. So you see why we were calculating E0 cell, because we need it here. So that was why we calculated E0 cell first, because we needed it. So delta G0 is equal to minus. Now the problem comes. What is our N? N represents what? Number of what? Number of electrons. What's the number of electrons here? So our N is what? 2. Because the number of electrons here is 2. So 2 times, what is the value of F we're giving? 96 what? 485. times E naught cell, we've calculated it as what? 0.096. So delta G naught is equal to, calculate everything here for me, minus 2 times this times this. We give us what? Please press your calculator. Minus what? 18525. 0.12. What's the unit? Joules per mole. Now this is it. Let me ask you a question. Is this reaction spontaneous or not? Will it be spontaneous or non-spontaneous? Spontaneous or non-spontaneous? Spontaneous or non-spontaneous? Now if delta G naught is negative, it says what? Spontaneous, right? Negative is hexagonic now. Spontaneous. If E naught cell is positive, it is what? Spontaneous. So you see, they are not contradicting. If E naught cell is positive, we said it's spontaneous. If delta G naught is negative, we say it's spontaneous. So the overall reaction is spontaneous. Please, anytime you are given a equation like this, and you're not given the equation of the reaction, the first thing you have to do is to figure out how to write the equation of reaction. Then after writing it, you divide it into half equations. Then you calculate E naught cell. E naught cell is that of reduction minus that of oxidation. Then you substitute your value from in this formula. Delta G naught equal to minus minus NF E cell. Then you substitute and you get your answer. If you want to put this in kilojoules per mole, this will be minus what? 18.525 kilojoules per mole.